Hello Math 7. This is your Unit 2 review where we've been talking about proportional relationships all unit. So on this review, I'll go through about 11 problems with you that should help you prepare for your test. If you are not in Mr. Gillis' class, if you're watching elsewhere in the world, again, this is for the Illustrative Mathematics series for grade 7, Unit 2. All right, number 1 says when you mix two colors of paint in equivalent ratios, the resulting color is always the same. So again, I'm making equal ratios. Complete the table as you answer the questions. So we've got blue paint and yellow paint, and we've got this ratio of for every 2 cups of blue, I use 10 cups of yellow. Number 1 asks, how many cups of yellow paint should you mix with 1 cup of blue paint to make the same shade of green? And explain your show. Okay. Well, what I see right away is that I have, let me try to get my pen up here. Come on, pen, work with me here. There we go. One relationship that I see here is when I start with 2 cups of blue paint, but then I'm trying to figure out how much I need for, if I only use 1 cup of blue paint, but I want that same shade of green, I need to make an equivalent ratio. So what I did here is I halved my recipe, right? I multiplied by half or I divided by 2. So the same I need to do here, I need to multiply by a half or divide by 2. That's the same thing. So 10 times a half is 5. Okay? Number 2 says, make up a new pair of numbers that would make the same shade. Explain how you know that they would be the same shade. Okay? So I have 1 to 5, I have 2 to 10. I could go, if I use 3 cups, and again, I could think about this as tripling my recipe. Okay? So 5 times 3 would be 15. So another ratio would be 3 to 15. Another way you could say, maybe you just doubled your original. So maybe you said, okay, I started with 2 cups of blue, 10 cups of yellow. I could just double that. So I could say 4 cups of blue and 20 cups of yellow. Just doubling the blue, doubling the yellow. That would give you that same ratio. Number 3 says, what is the proportional relationship represented by this table? Well, the proportional relationship is between the amount of blue paint that you use and the amount of yellow paint that you use. Okay? It doesn't really ask for a number here yet. That's what number 4 is. But it's just that relationship between the amount of blue and yellow. I'm not going to spell all that out. That would take a lot of time on my digital pad here, but you get the idea. Number 4 is where it wants that number. What is the constant of proportionality and what does it represent? So this unit we talked a lot about this idea of the constant proportionality. This was the K value. And what that means is, what did we multiply by every single time to go from my X to my Y, my first row to my second row, here to here, here to here. Okay, and you can see each time there, we're multiplying by 5. Okay. What does that represent? That represents the cups of yellow paint needed for 1 cup of blue paint. Okay. Again, that represents the yellow paint needed for each cup of blue, or for 1 cup of blue, same idea. Okay. Number 2 kind of gives us a table again. I know on your paper I might not have 2 and 3. Kind of got cut off when I was printing, but we can still go over them. It says May is filling her fish tank. Water flows into the tank at a constant rate. Okay, so the rate is the same. Complete the table as you answer the questions. So in a half a minute, the number of gallons that goes in the tank is 8/10 or 0.8 gallons. Number 1 says, how many gallons of water will be in the fish tank after 3 minutes. So we're looking for this answer. How do we know? And then we're looking for how long it will take to fill 40 gallons. Well, using a table can often be helpful. I know that to go from a half to 1, I'm doubling, I'm timesing by 2. So here, do the same thing. 0.8 times 2 is 1.6. Okay, so that means for every minute that goes by, I can fill my tank with 1.6 gallons of water. Right? How do I find for 3 minutes? Well, how do I go from 1 to 3? I'm getting 3 times as big. So I have to take 1.6 times 3. When you do that, you should come up with 4.8 gallons. Okay? And then the last one, for number 2 here, it says, how long will it take to get 40 gallons in my tank? Well, one trick that I like to use here is I like to find my K value. So how am I going from X to Y each time? What am I multiplying by to go from my time to my water? Well, my K value that I'm multiplying by is, what 1 times what number is 1.6? Well, 1.6, that's nice and easy for us when we find kind of a unit right there. So, to go from X to Y each time, I'm multiplying by 1.6. So to go the opposite way, I would have to divide by 1.6. So I'd have to take 40 divided by 1.6. Let's grab my calculator here quick. 40 divided by 1.6. I come up with 25. Okay? So that would be 25 right here. All right, and then the last question says, what's the constant proportionality? I actually did that in number 2 because it helped me solve number 2. So 1.6 for number 3 is my constant of proportionality. Moving on to number 3. It says snow is falling steadily in Syracuse, New York. After 2 hours, 4 inches of snow has fallen. If it continues at the same rate, how many inches of snow would you expect at 6.5 hours? If you get stuck, use the table to help. Awesome. Definitely encourage you to do that. Okay. I know it looks like to go from my time to my inches, I'm multiplying by 2. So multiply by 2 here as well. Looks like it'd be 2. You could have said, okay, to go from 2 to 1, you're dividing by 2. So 4 divided by 2 is 2, same relationship, right? Okay. How about over here? How about my time and how long did it take to snow 1 inch? Well, if it took 1 hour to snow 2 inches, and it's a steady rate, if 1 inch fell, it only took half of an hour, so 0.5 hours. Let me kind of zoom in a little bit here, make this a little bit bigger for you. There you go. Okay. So I know every 1 hour that goes by, it snows 2 inches. So again, this table can be really helpful. So how do I go from 6.5 hours to figuring out how many inches of snow fell? Well, again, I'm just multiplying that by 2. That would give me 13 inches. And then the last one says, what about X hours? So how can I find any amount of time? Well, again, this constant proportionality is we're just multiplying by whatever our X is by 2. So we're taking 2 times X. So if I want to write an equation to find that, I would say Y equals, to find out my number of inches, I take 2 times however many hours have gone by. So Y is equal to 2X there for number 2. And number 3 says, how many inches will fall in 24 hours if it continues to snow at that rate? Okay, so again, to find my number of inches, I'm taking 2 times the number of hours. That will give me 48 inches. And that is a lot of snow. I don't know if I'm ready for that yet. It's not November. Moving on to number 4, an albatross. Kind of looks like a seagull. It is a large bird that can fly 400 kilometers in 8 hours. at a constant speed. Using d for distance and t for the number of hours, write an equation that represents this situation. Okay, so if they give us that equation, which distance is equal to 50 times time. Okay. Number 1 says, what are two constants of proportionality for the relationship between the distance in the kilometers and the number of hours? And what's the relationship between these two values? So right away I can tell that this is my k value. Remember we talked about the equation y equals k times x, where k is our constant of proportionality, okay, that rate of change. So what's the relationship? Well, for sure, 50 is one of them. And the second one, remember, if we were to rewrite this equation, if we were to change this to x equals something times y, we have to make the k value its reciprocal. Okay, so instead of saying 50, I would say 1/50th y. Okay, so 50 and 1/50th are our relationships there between the distance and the number of hours. And then what's the relationship between these two values is the second question. Well, they are reciprocals. Remember, anytime you rearrange your distance, or your x and your y, in this case distance and time, you have to flip your k value to its reciprocal. Okay? So write another equation that relates d and t in this context. Well, okay, I'm just going to switch my distance and time. So I'm going to say time is equal to 1/50th times the distance. Okay, just switching that around. Number 5. It says, based on her recipe, Elena knows that 5 servings of granola have 1,750 calories. If she eats 2 servings, how many calories does she eat? So again, for this one, to me, like we started off, it's going to be really helpful to make a table. You don't have to, but I'm gonna. My S stands for my servings, and my C stands for my calories. What do I know? 5 servings is 1,750 calories. And this question is asking, what if you eat 2 servings? Well, what I'm going to figure out first is, if I just eat 1 serving, how many calories is that? Well, to go from 5 to 1, that's dividing by 5. So I have to take 1,750 and divide that by 5. That would give me 350. So that means there's 350 calories for 1 serving. To go to 2 servings now, I just double that. So times 2 would give me 700. Okay, so 700 calories she eats if she has 2 servings. Number 2 says if she wants to eat 175 calories, how many servings does she eat? All right, so now I can see a relationship there. To go from 350 to 175, you're just having that. So what's half of 1? Well, easy, that's a half. Okay, so really, making these tables can really be helpful. I'm going to write that down here. Might be helpful for you to do on a test too. Last one says write an equation to represent the relationship between calories and number of servings. So again, if I thought about this as x and this is y, my original equation is y equals k times x. So instead of saying y, I'm going to say calories is equal to, what did I find was my constant of proportionality? Right here, how did I go from 1 to 350? Multiplied by 350. So 350 times the number of servings will tell you how many calories you have. Of course, you could flip that around like we did in the previous problem. So you could also say something like S is equal to 1/350th C, but I think this is probably the more common one that you'll see. Okay, moving on to number 6. Okay, in this problem it says, based on the information in the table, is the cost of the apples proportional to the weight of the apples? Okay, one way I can look for proportionality is to find that k-value. Okay, so is my k-value the same from when we go from our pounds to our cost? So how can I figure out what I multiply by to go from 2 to 367? Well, that's not obvious, right? It's not like it's a whole number, because we have a decimal here. So to work backwards, we have to divide. Let's take our y value divided by our x value and see what we are multiplying by each time. That'll tell us what our k-value is. So for the first one, it's $3.76 divided by 2. Bring up my calculator here. $3.76 divided by 2. That equals $1.88. The next one says it's $5.64 divided by 3 pounds of apples. Hey, gives me the same answer. The next one, $7.52 divided by 4 pounds of apples. Look at there, it's $1.88 each time. So what that tells me is that each pound of apples, so each pound, I'm just abbreviating there, costs $1.88. So is the cost of the apples proportional to the weight? Yes, it is. It's $1.88 for each pound. Okay. Kind of the same idea for the second part. Is the cost of the pizza proportional to the number of toppings? Okay, so it's got 2, 3, 4, and 5 toppings, and it's got different price there. Let's check and see. What are we multiplying by to get from my x to my y? Do I have the same k-value here? Here you go. Just bring out my calculator. $11.99 divided by 2. So that would tell me it's $5.99. Okay, so here we've got $5.99 for a one-topping pizza. Let's see. So if it were proportional, two toppings would be $11.99. Let's see if it's proportional for the next one. So if I took $13.49 and I divided it by 3, that gives me $4.49. Okay, so this is $4.49. So you can already see they're not the same k-value. It's probably going to be a no. Let's just double check that. Oops, sorry, I hit the wrong button. Let's just double check that for this one. $14.99 divided by 4 toppings. That gives me $3.75 if I round up. So $3.75. You can see each time we don't have the same k-value. We have a different k-value or a different constant proportionality. And that kind of makes sense. Usually you don't get charged on the number of toppings, and that's proportional. Usually it's like a certain amount for the pizza, and then it's plus toppings. You're not just charged differently for a different topping pizza. So that makes sense that this one is not proportional. Number 3 says write an equation for the proportional relationship. So that's this one. So again, I think the easiest way to do it is think about this column as being my y, my first column my x, and I'm writing this equation, y equals k times x. And instead of writing y, I'm going to write c for the cost of my apples. And I know that it was $1.88 per pound. So I'm going to abbreviate that P. So C equals $1.88 P for my equation for that one. Number 7 says, Andre is setting up rectangular tables for a party. He can fit 6 chairs around a single table. So 2, 4, 5, 6 around a single table. He lines up 10 tables end to end and tries to fit all 60 chairs around them, but he's surprised when he cannot fit them all. Number 1 says write an equation for the relationship between the number of chairs C and the number of tables T when the tables are apart from each other. So here it looks like when the tables are apart, it looks like I can fit 6 chairs at each table. So I'm going to use C for chairs and T for tables. The number of chairs that I need is equal to 6 times the number of tables I have. So for example, if I had 2 tables, I would take 6 times 2, that would give me 12. That would tell me I need 12 chairs. Okay. Now this is the situation where it said he was confused and surprised when he said he couldn't fit all 60. Well, that's because you're losing a chair on the ends. When you put them together, you're losing that space. Okay. So how could we write an equation for this one? Well, the number of chairs for this one, it looks like each table can fit, for sure, 4 chairs at each table. And then it looks like, so here's 4 at this table, 4 at this table, 4 at this table. And then it looks like at the end, there are 2 spots here. So I can add 2 at the end for those 2 end spots. So is the first relationship proportional? Yes, definitely. It's in that equation, y equals k times x. It looks just like that, except instead of y, it's c. Instead of x, it's t, and my k value is 6. It's 6 chairs per table, no matter what. But the second one, is the second one proportional? No, this one's not. And this is why he was surprised, because you're losing chairs on some of your ends. Okay? It's definitely not in y equals k times x form. Okay? It's got something added to the end. It had plus 2 added to the end. And that doesn't fit this equation that we've been talking about. The number of chairs per table is changing depending on how many tables you have. Okay, so the number of chairs per table is changing. And again, that's depending on how many tables you have. Okay. Moving on to number 8. We have a graphing one here that says, which graphs cannot represent a proportional relationship, and explain. Okay, so again, to have a proportional relationship, you need a couple things. You need, 1, your point needs to go through the origin, or 0, 0, and 2, you need to have a straight line. In other words, you need to have that pattern of, if I go over so many, I go up so many. I have to keep going over the same amount and up the same amount, kind of idea. Okay, so you need to have a straight line. So if I'm looking at these, which one does not go through the origin? That would be letter B. Definitely doesn't go through 0, 0, so that cannot be proportional. And which one is not a straight line? Well, that's letter C. This one is definitely curved. It's kind of going like this, kind of looks exponential. But letters A and D, if you notice, they both go through the origin, 0, 0, and they both have straight lines. So I know A and D are proportionate. B and C are not proportional relationships. On to the next one, number 9. Says that water runs from a hose into a bucket at a steady rate. The amount of water in the bucket for the time is being filled as shown on the graph. Okay, so we have time going on here, and we have water in gallons on my y-axis. Okay, so this is my y-axis, just a reminder, and this is my x-axis. Okay, it says the point 12,5 is on the graph. So over 12, up 5. Remember, your first coordinate is your x, and your second coordinate is your y. That's all the time, x comma y. What do the coordinates tell you about the water in the bucket? Okay, well remember, on my x-axis, I'm talking about time. So 12 is 12 seconds. So that means after 12 seconds have gone by, there were, and we go up to 5 gallons of water. I'm just going to say H2O to abbreviate it, in the bucket. Number 2 says how many gallons of water were in the bucket after 1 second. Label the point on the graph and show this information. Okay, something important to remember is wherever 1 is on our x-axis, that y value, however much we have to go up, is our k. Okay? Because remember, our k value is equal to our y over our x. Okay, when we're finding after 1 second, we're finding kind of like a unit rate. In other words, we're finding that constant of proportionality, or that k value. Okay, so if I look and I take a guess, just to get an estimate here, after 1 second, it looks really close to a half. That's kind of my best guess. That's my estimate. All right, but how can I actually find that? Well, I can take and find my k value. So I know my y. It told me one of my y coordinates was 5. And it told me one of my x coordinates was 12. Okay, so if I find that k value, it tells me it's 5/12. Okay, and that's how many gallons were in 1 second. Now, is 5/12 close to a half? Absolutely. Remember, it's really close to 6/12, and 6/12 is the same thing as a half. So that tells me that my estimation is definitely right. Moving on to number 10. Says Noah and Diego left the amusement park's ticket booth at the same time. Each moved at a constant speed towards his favorite ride. After 8 seconds, Noah was 17 meters from the ticket booth, and Diego was 43 meters away from the ticket booth. Okay. Which line represents the distance traveled by Noah, and which one by Diego? Label each line with one name. Okay. So first thing it tells us is that they left the ticket booth at the same time. So that's kind of their starting point. They're both leaving the ticket booth at the same time. That's that 0, 0 where they both start. Okay. After 8 seconds, so our time, notice, is on the x-axis. It says after 8 seconds. Well, this isn't labeled, but I can just guess. Maybe 8 seconds is like right around there. Let's just say this is 8 seconds. If I were to extend that point up here, like this, and I could extend their lines a little bit if I needed to, it tells me at that time, Noah was only 17 meters away, and Diego was 43 meters away. So this is the distance traveled. This person right here has a lesser distance traveled than this person right here. This person went a lot further if you look at the y-axis in meters. So let's see, Noah was 17 meters away and Diego was 43 meters away. Okay, so this one here is definitely Diego. He's 43 meters away. He's gone a lot further than Noah. Noah was going a lot slower. He's only 17 meters away from the ticket booth. Okay, so this one's Diego and this one is Noah. Explain how you decided which line represents which person's travel. Okay, I kind of did that here. I just picked a point of 8 seconds, and I looked at the y value to see which one was greater or further away. Okay, moving on then to the last problem. It says, Elena went to a store where you can scoop your own popcorn and buy as much as you want. She bought 10 ounces of spicy popcorn for $2.50. Number 1 asks, how much does popcorn cost per ounce? Number 2, how much popcorn can you buy per dollar? Write equations for those for number 3, and then sketch their graphs. Okay, so first off, I think it's helpful to make a table. Kind of been talking about that in these previous problems, how it can be helpful to make a T-table. So I have ounces of popcorn, and I got the money cost. So I know she buys 10 ounces, and it costs $2.50. It's bad money, so okay. It says how much does popcorn cost? So we're looking for the cost per ounce. So that means for 1 ounce. Well, that's pretty easy. How do we go from 10 to 1? Well, we just divide it by 10. So I'm doing that same thing here, dividing by 10. Remember, mental math trick, dividing by 10, move your decimal 1 to the left. So that's $0.25. Okay, so 25 cents per ounce. Number 2 says how much can you buy per dollar? All right, so now it wants to know colors here. How many ounces can we buy for $1? Well, again, it's pretty easy to go from 25 cents to $1. You're just timesing by 4, multiplying by 4. So over in our ounces, multiply by 4. 1 times 4 would give us 4 ounces. Okay. Number 3 says write 2 different equations that represent this situation. Use P for ounces of popcorn and C for the cost in dollars. Okay. Well, I think the easiest one to do first is the one that I'm accustomed to doing is labeling this X and this Y, and then saying Y equals K times X. So my Y value in this case is cost, so I'm going to say C equals whatever my constant of proportionality is times my X value, and my X value is ounces, and it says use P for popcorn in ounces. So how did I get from 1 to 25 cents, or how did I get from 4 to 1? Well, I'm just multiplying by 0.25, 0.25p. In other words, it costs 25 cents per ounce of popcorn. Now, if I were to rewrite that, remember, if I change the P and the C around, I need to make this its reciprocal. Well, remember, 0.25 or 25 cents is the same fraction as 1/4. And then when I make this its reciprocal, change the numerator and the denominator, it becomes 4/1, which is the same thing as 4. So you could also say, if you take 4 times the cost, you could find how much ounces of popcorn you could get. So both of those 2 equations would work. The last one says choose one of your equations and sketch its graph, and be sure to label the axes. So to do that, you can do either one of these, it doesn't matter. Again, I'm just going to go off what I made originally up here in my table. I had ounces for my X value, so I'm going to put popcorn in ounces on the bottom. I'm going to put my price or my cost on the Y value, and that was in dollars. Okay. I know that I had 10, so I'm going to put 10 here, maybe 5 here, 0, so it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then my cost, I know it was what? It was like $2.50, so I can probably go by 50 cents. So 50 cents, $1, $1.50, $2, $2.50, $3, so on and so forth. And I know 10 ounces was $2.50, so that's about like that. Put your dot right about there. And then it'd be helpful if you had a ruler. I don't have a ruler here, but go through 0, 0, connect your line to your dot a little bit straighter than what I did, but you kind of get the idea there. Okay. If you guys have any questions, let me know. I'll be happy to help you. But that does it for the review. I'll talk to you guys later.